So friends, in previous lecture, now we are into AI and its application, artificial intelligence and its application in our complex engineering system. So we saw the background in the previous lecture introduction. Now we'll see through some application example what are the models and methods, because if I give in isolation these tools and method, it may not work. You may not get the right idea what they are, what they do, and what we can expect them to do when you build your own systems. So even though the name is AI model and methods, it has been illustrated through some applications. And if I have to tell explicitly, the one paper that I published, that is operator support system. So I have really made a toolbox out of that, and that I will be presenting here. So if I have to introduce the toolbox in terms of, so let us have a look at how we were doing, and that means then you will know how you have worked in advanced stages. Initially, they were plant control and mimic panels. Static mimic panels were there, not like dynamic computer screens. They are through colors, through icons, and we were able to understand what is the process going on into the plant. And so that was something like what is happening in the control room. Okay, and then there used to be one control console also, where we used to operate or maneuver the systems or the core plant itself. Okay, so it's not only observing the signals, operating those remote equipment, and then affecting actions also, including emergency actions. And then there is a document called technical specification. You have to remain within the umbrella of technical specification. It can be said as a safety document which should not be violated. If we violate that document, it becomes a regulatory case. So that was, so safety is ensured through the document. We open the document, and sometimes during training you know the condition what has been specified in terms of parameter settings, in terms of conditions that are related to any subsystem systems, and these are called limiting condition for operation parameters. And then the first important thing is safety limits. They are highest level of stipulation of technical specification. So if those things are violated, that means there is a safe to safety. That is something like an interpretation. Nothing has happened, but it is a resilience built into the system, and these are the parameters that has been recorded in the safety report. And then we would have normal hard copy operating procedure, emergency operating procedures. We are talking about AI as emergency operating procedure. Does not mean they were not there. They were there, and they were all approved a document. Okay. Administrative support, line of authority, control room was not operating on isolation in round the clock shifts. They can consult to their maintenance part, their superior, and there was all support available. Ecosystem, like organizational ecosystem was available. Maintenance schedule, procedures, they were worked out. Regulatory compliance requirements, agencies were working to coordinate with the regulatory agencies, and then area maintenance log, coordination and communication protocol. All these things are in place, and there is absolutely no problem. Emergency operating procedure was in the form of hard copy. If you see traditionally, even though operator training for handling the postulated scenario often managed through simulator and all that, it was felt that during certain condition, when the available time window for taking the action and the event itself that time requires, this was a little complex scene. So it was felt, why we don't have a computerized system. Okay, then it takes definitely grasping of what is going on. Even though all signals and mimic panels are informing, it takes time. Certain amount of predictability inherent to rare events. Rare events do not happen in the life of the plant. in these systems, they are meant to manage the rare events. They are called safety system, and they are tested to check their performance and their availability. But this event don't occur. So there will be some sort of a, see, when we don't do anything on routine basis or even non-routine basis, once in a year or 2 year, definitely the guidance is there in the document, but how it will evolve, what are the, because every new event has got a new feature. Okay, so how to manage those things, those kinds of uncertainty are always there with the rare events. So then you talk about the deep learning. Now henceforth we will be talking about deep learning, and we will be talking about how to go deploy it through ANN. And one more, production rule based expert system, that we will be talking about, because that is meant for diagnostics. So essential feature of deep learning involves handling and management of complex and big data. That was the problem. Why ANN failed in the beginning, in say early 90s. So why it failed? So big data, particularly non-linear problems. And control room, what it encounters is a sort of a non-linear problem. If we see the process signals in isolation, but when they make a ensemble, then it is required that we grasp the situation early by correlating the signals and phenomena in the control room. Use of ANN is excellent tool for prediction, because it has been trained. It has been trained robustly. It has been trained for known pattern. It has been trained for some error in pattern where there is one or two signals are missing, fuzzy data is coming in. So this could happen, because that is how uncertainty can be captured. So ANN have shown their capability. Pre-processing of feature. So now as part of deep learning, we understood the big data is there, but its analysis, feature extraction is very important, so that ANN drafts them, and at the outset let me tell you, ANN is a black box. ANN is a black box. Structure is that it produces result, but then now there are efforts to understand what happens at the hidden layer number 1, what happens at the hidden layer number 2, what happens at the hidden layer number n, and the output and input layer. So now there are efforts, we are trying to understand, but it is like I cannot explain it. It is a non-linear function actually. Often more than one hidden layers are used in DN, deep learning DL, monitoring symptoms at the hidden layers to assess the impact of transfer function. There is transfer function we will discuss when we discuss the node in the ANN, application requiring prediction based on complex data trends. So data is challenging all aspects of our modeling and analysis and decision making, and that is where now the deep learning techniques have come. And in I think secured industry, it is better to use supervised learning. There are unsupervised learning also, but supervised learning should be used. And if we want to do pattern recognition, then in limited sense we can use unsupervised learning, because the data itself will reveal its structure if we do a number of iterations. AI modeling for emergency scenario. So we can see that how to build an ANN. First, if I have to build a system, I should know what are the reference condition, healthy condition, because there will be always a comparison from reference condition to transient, and after transient the plant real state, and then we will be able to perform fault diagnosis. So we can say, and then in the context of plant condition, we know that there are two broad areas: normal operation and deviation from the normal operation to emergency conditions. There are in between many stages, So, but then we will talk about these two as far as this lecture is concerned. Reference condition is something when plant is operating, and this is something a benchmark that is available to us, or reference condition available to us for building a diagnostics and transient and other things. But we will be focusing more on two parts: transient conditions and fault diagnosis, because going into the operational routine transient is not our this thing, because we are building a system. Let us keep this complexity to a certain level only. Otherwise, the negative effects start actually. Now, what is the objective? Objective is to help operator, and since the knowledge has been built and embedded into the system and system has learnt it, it is providing the advices, use or ignore, that is up to us. But one support which is not getting affected because of like cognitive stresses, that system is available to you. So, operator's cognitive level, stress level, if it was going up, there is a computer system which can support his thinking or his decisions. The architecture of the operator advisory system that we are talking about typically is like this, because these are the components I was telling you. Let us understand the components which are there into the system. So, there is one module, it is called ANN module. This module is meant for transient identification, and there is a plant, and from plant this data are coming here, and then it is processed and fed to the ANN. I have not shown here pre-processing element and all that. Now, the transients has happened, and now the system parameter reading got stabilized to some other position. Okay. Equipment also, the plant configuration changed from normal operation to certain shutdown condition, let us say, but then the system should operate for shutdown condition also. So, if any deviation from shutdown condition or safe condition, this is safe condition, it should not take plant into, so it can be expected that some, like if there is a ANN transient was class 4 power failure or normal power failure, then the signal will go after the plant got stabilized to do diagnostics whether diesel generators have started. If they have not started, what is the reason, whether it is a breaker failure, whether it is a lubricating oil failure, this failure. I have explained these things in my paper which was published in 1998, but it gives a complete perspective, and you will find much more than what I am talking here because of limited time and this thing. So, a knowledge base is built, that means at least critical component should form part which are playing the safety and reliability of the plant, they should be forming part. And then here it is a database, it is not a knowledge base, it is a database that should be there. So, please see knowledge base and database. Okay. And these two together, there is an inference engine. You would have known knowledge based system, or it is based on the rules, production rules, if and then inference engine, and then it goes a closed loop and action is taken here. Okay. So, from ANN we have plant data which is coming online. We go to ANN, identify the transient, perform the diagnostics here, and output of operator advisory system is a screen is there, and then there is an operator, then complex engineering system, this operates in a closed loop. Okay. And objective is to ensure safety and reliability of the plant. So, let us see how an ANN, of course, all of you would have seen ANN architecture, but just to have a continuity, typical ANN, the basic of this is like this. If there is a ANN 3 layer input layer, hidden layer, output layer, each layer will have number of nodes. So, here you will understand the number of data will govern this x to xn. There are 20 data sets or 20 vectors, then we have 20x here. So, input layer, and these are called, this is called hidden layer. So, data at input, then they are processed. I am using the word process, I will explain in the next slide what happens on these nodes actually, and then they travel, the data travel and goes to the output layer. In simple words, the error correction is performed. This output does not go when you are in training, it operates in a closed loop. But when the ANN is trained, then input will be there, output will be there. This ANN has been trained, so it operates in two modes. One is training mode, all these data are there, and then it is getting trained, and once the training is completed, then this in real time these conditions are imposed or they are received in the module, and then input layer it processes, hidden layer it processes the second function, and output layer it presents the result, whether it's like a whether whatever it has learned it produces the output. So, the number of nodes in input and output layer is depends on the application you are having, or you are trying to present them as a result of the ANN, and this is the input layer which is governed by number of input that we are feeding to the ANN. And hidden layer, a lot of research is going on whether the number of node should be more or less than input layer. So, all sorts of R&Ds are there. Then what it does actually, now with the deep learning concept we are having some understanding what kind of function it is playing over here. Since there are more hidden layer, we will talk about those things in the coming slides. So, that is how what you have. So, now you would have understood when I am talking about NN, what NN means, and here it is not a mathematical algorithm, it is a non-linear algorithm that is operating. So, there is a transfer function at the node level, but what is that transfer function? It will have its own unique transfer function, okay, and which will be most probably in linear domain, non-linear domain. So, and then these data, whatever we because we move from ANN to machine learning to deep learning, the difference is involvement of domain experts. This could be a takeaway for anybody who is working on intelligent system. Data can converge sometime, but domain experts role is critical for a successful operation of an ANN. Now, we saw the nodes. What happened at the nodes? It is a non-linear function, you can see here. This is a constant which can be called as bias, you know, and then we have all xi's. So, xi's. So, the output is a function of a bias and this xi's input, and then they are added from 1 to n. There are n input 1 to n, and then CIE they represent training coefficient, momentum coefficient, how they are built into the system, because the training rate, if we have too fast a training rate, then the the ANN architecture will mug up the system, it become hard, you know. So, that we would not like to have. So, all these factors are selected, and of course, it is clear phi is a non-linear polynomial function. Okay. So, what is happening actually in practice here, we have seen this generalized formulation over here. Every node like one will be, first will be bias node preferably, because that stops ANN things floating, you know, it provides a reference. The way we have a BIOS on a electronic module, similar function is there. So, the X1, X2, X3, they are coming from P1 layer, then we have the input and we have weight for every link that is going to the node. So, weight and the bias, they get multiplied. So, how weight and not bias, input, they get multiplied plus bias, Bj is represent bias, and then suffix and this thing, sub and super notation, they are basically to tell what is what, because when you develop a program, we should know that how things are flowing from previous layer to next layer, from one node to another node, from one layer and then from input to output. So, that is why this has been given, otherwise this is bias, these are the weights, and these weights are in ANN there is a provision to randomly initiate this weight, you know. So, from here only it starts. For every connection, not node, for every connection we will have a weight, this will have its own, this will have its own weight, W2. Why? Because each parameter that is coming in, is not equally responsible. There will be some parameter. Let us say if I say classical power failure signal, the power failure signal should have more weight, and then the consequences, the failure of pumps and all that, they are consequences of that. So, that cannot have the same weight, but at the same, if I see the conversely, if my suppose for by chance my power failure signal does not come because of any situation, then so many pump failures should tell me, oh, this is a power failure condition. So, all NN comes true on this kind of situation, the way a human analyzes a system in control room, the NN does in a much faster way without confusion. Here there is no confusion because NN has been trained for doing certain thing and it does it, but it does it very fast, which operator might take some time, So, what we have done here is we have formed a netj function which is nothing but summation of all the weights and xi's, they are coming, and plus BIOS. Okay. So, we have, and then these things are processed through, this is a sigmoid function. I am using a new term, but we will have a table, what are the different table, and the sigmoid function is like this, it looks like this. So, the signal varies from 0 to 1. So, it will be having like this not S shaped, this is it is going to 0, and this is how it can be called as a transfer function. When this information is available, how it produces an output like this will be governed by this. So, activation function, this is called sigmoid activation function, or overall it is a transfer function at the node, is very critical to success of applying an NN, and of course NN configuration altogether. Now, so this is say sigmoid function where the netj has been put, and this is how it brings in the transfer function type of this thing, and there are many activation function available in the open literature. I will show on one of the slides. Selection of an activation function, yes, is very critical. It comes by practice, it comes by knowledge, and it comes by number of iteration you do with the same problem with different function, which is giving me the right solution. That selection has to be done, and not only for the available vectors. If I anticipate or some new situation comes, then what should be my transfer function, because they should not have a domain operating in certain domain, not operating in other domain. An analyst knows by practice that how to optimize or select the transfer function or activation function. Connection weights, these weights are randomly analyzed, but what is training? If you want to understand when the algorithm is traveling from input to output computation, there is an error factor computed from what has been given supervised learning and what is the output. So, that error factor will be connected through the weight, and that this vector factor tells us the quantum of training that has been done actually to the ANN actually. So, updating of weights. So, each vector weights are updated. Yeah, this is what I am trying to tell. They are getting modified and updated, and when training is completed, that means how you will say training is completed? When the assigned or target error has been achieved. Target error is what? Let us say 0.0001. That is my target error. So, if the convergence has taken place in the same manner that we have done this, the number of iterations have converged the NN to say that the error is now, and that error is also at the output layer level. So, this is called average error at the output layer, and sigmoid function is calculated this output, xj is calculated based on this multiplied by weight, then it goes to the next and all. Yeah. So, I was talking about the activation function in NN can be step function 0 and 1 like crisp logic, it can be sine, plus, minus. So, that is a kind of domain that we have over here. If you are dealing in data with plus and minus, crisp sign activation can be used in map and binary outputs. So, and prediction, it is a non-differentiability prevents its use for creating the loss function and training time. Okay. Now identity function fx is equal to x. It is the simplest function that we can have, this one and this one we can have, and this I told you our sigmoid function. Okay. And now this hypertangent function is being used extensively. I would say it is one of the modified or translated form of so the activity function that has been claimed work almost always better than the sigmoid function is 10 hyperbolic function. 10h means 10 hyperbolic function. There are many more functions you can just read. Now how the problem is formulated, training procedure, this is the output vector that we have given. Why I have given 1 1 1 at the output? If I have some condition which is next to that, it will become 1.1. So I have, for any condition to coding, I will have this one spaces, this 0 spaces available. Now sometimes here, sometimes here. So diagonal matrix 1 1 1 and I think it works very well. Distinct matrix you get actually. Now what is my training configuration? Number of neutrons in input layer for the project that I did, which is there in my publication, was 42. Then number of nodes in the input layer is let us say 40 input 42 and output 14 layers. You can see for yourself 14 vectors are there to identify it for these transients, and number of hidden layer 1. In those days there was a culture to have only one hidden layer. Number of nodes in the hidden layer and the learning rate, momentum coefficient, an optimization was required to do learning adjustment on, so that our ANN learning is faster. Okay. Momentum rate is basically the ANN should not get into local minima and then it should take it out. The moment it gets trapped into local minima, a shallow thing, it should give a kick. Momentum is give a kick to come out of that, so that convergence can continue. Maximum error was this one, 0.001, and the maximum individual error at the node was 0.001, but average error was 0.001. When you got 0.001, that means your ANN algorithm has been trained. Time for training the ANN was 3.5 hours, and number of iteration was, now if you have a software, ANN software, training might happen in let us say 100 or 80 or 120 iterations. But this was a time when slow computers were there, and now due to the computational capability, complex microchips are available. They can do functions in nano seconds, and that's how. But in earlier time it was 80,000 was the thing, but the prediction capability was very good. That is what my claim is. It used to take 3.5 hours for training itself. And how the training, so this is the input vector. You can see here total 42 nodes will be there, 21, 11 and 10. So 10. As I told you, pre-processing is required. How to present the transient, alarm and trip and process parameter, and how they should be assigned the weights. So these are instrument reading, they are instrument, it has been normalized. So normalized was a pre-processing function that was done for parameter reading, and 0 and 1, and while training, if you keep 1, it takes a lot of time to get trained. So is it possible to get 0.9 for 1 and 0.1 for 0, and those kind of trials were done to increase the training efficiency. So this training is going on. You have reactor state input you have developed in one table. Now you put input to the ANN over here. The ANN will predict the error function is being developed over here based on the reactor state code, and desired output is there. So ANN output is there, design output is there, error will be, and then BPN algorithm will give feedback to ANN for further training till the target average error at the output has been achieved. Okay. So this is the training algorithm. It is called back propagation feed forward and back propagation training algorithm. How this is the error model at each output average model RMS error was computed, number of patterns in the input layer number. So, all this information is there, and ERMS was 0.001, that is we are talking about RMS error. And you see how convergence happened. RMS error is converging during the training, you can see here, and finally it is come to its a goal of 1 into 10 to the minus 3, and function was sigmoid function, and training rate was 0.35, and momentum rate was also 0.35, and of course there was a verbose function, we will not discuss here, but momentum coefficient was the, so let us see the first line only, which is important. These are other function, sometimes you do it for verbose function was there, but we will talk about the sigmoid function, because this sigmoid function is still being used. Number of iteration you can see here, it is almost like 1,80,000, almost it is reached actually. So, this is what the training was. So, you learned, you peeped inside the ANN functioning and all, and now we are into a third lecture.